Okay, so I'm trying to save just a little bit of class time, make tomorrow in class a little bit better. There is something that I have on tap already designed for tomorrow, and I thought if I could just hit it a little earlier, that would be helpful. It's been a little while since we've done any trig identities, so I was going to remind you a little bit about some trig identities, and then use that to show you what the derivative of the sine and cosine are specifically. So I'm not going to go much beyond that. That won't take very long, just a quick derivative of the sine and the cosine. So let's see what we've got going on. So before I actually launch into the calculus side, let's remember just a little bit from math analysis. There are two identities that I want to remind you about. One of them is the sine of alpha plus beta, and the other one is the cosine of alpha plus beta. Now, it's been a little while since we've done that. Remember, these are identities, so it really doesn't matter what alpha and beta are. These are always true. And so the identity that we had for the sine of alpha plus beta was the sine, cosine, and then if there was a plus in the middle, we went with a reversal of the cosine of alpha and the sine of beta. The cosine was a little different because it went cosine, and then if there was a positive in the middle, we subtracted. And then, funny, I just said it, but I wrote the opposite. And then minus the sine of alpha, sine of beta. And I'm going to actually use both of these identities in the different proofs. So let's take a look at, again, the derivative of the sine. But we're going to go back to the formal definition again. You're going to see that we kind of are forced to do this frequently. So let's see what happens if someone asks us to take the derivative of the sine. It's kind of a surprising result. So let's see. This would be the limit as h goes to 0 of the sine of x plus h, that's f of x plus h, minus the sine of x itself, which was f of x itself. Now, this is actually kind of this thing right here where we're calling x alpha and h we're calling beta. So that formula is the limit as h goes to 0. It's going to look bad for a moment, but it would be sine cosine plus cosine sine. Again, minus the sine of x because this whole argument here was the sine of alpha plus beta all over h. Now, this is going to be similar to one of the problems that we did in class today, as it turns out, that if you look at these two particular terms right here and right here, I'm going to regroup them just a little bit. And I'm going to say then that we would have the limit as h goes to 0 of the sine of x times the cosine of h minus 1 over h. And then plus we have the limit as h goes to 0 of the cosine of x times the sine of h over h. And I had intended to remind you of this as I got started, but the squeeze theorem long ago, we figured out that the limit as h goes to 0 of sine h over h was 1. And in a similar set of logic, we actually learned that a little while ago. It's one of the Maximus things that we did from Mr. Corpy. We had a series of arguments that established that the sine of h over h is 1 and the cosine of h minus 1 over h was in fact 0. Well, using that information right here, again, noticing that there is no h here, the limit does not affect the sine because that's just sine x. This value right here is 0. And then over here, the limit doesn't affect the cosine because there's no h in it. But the sine of h over h under its limit as h goes to 0 is 1. So according to all this information, it's an amazingly simple result that if you take the derivative of the sine of x, you just get the cosine of x. That's kind of strange, but literally the rate of change of the sine is identically the cosine. So everywhere where the sine is increasing, the cosine is going to be a positive function. There's just a lot of interesting little connections there. Well, it probably won't surprise you if the derivative of the sine is the cosine, then the derivative of the cosine is probably going to be something that relates to the sine. So let's take a look at that one as well. So again, using the derivative of the cosine of x, going right back to the definition, that would be the cosine of x plus h minus the cosine of x over h. I'm going to use that identity up top, the cosine of alpha plus beta, right there. And we're going to then have the limit as h goes to 0. That's going to be cosine x, cosine h, minus sine x, sine h, minus the cosine of x, all over h. Now, just like the previous problem, I'm going to go ahead and group these two pieces here together. In doing that, I have the limit as h goes to 0 of the cosine of x, which is going to leave me with the cosine of h minus 1 over h, minus the limit as h goes to 0 of the sine of x times the sine of h over h. Well, I'm running out of room on my paper, but it's not a big deal. Since we know from above that this is 0, this entire thing is the cosine of x times 0, which is going to be gone. We also know from above that this is 1. So as that happens, I just have the sine of x in this argument, but there's a negative right here. So as it turns out, the derivative of a positive cosine is actually the opposite sine, and that kind of finishes this particular part of the story. And that's the derivative of the cosine and the sine, and that'll just save us about 10 minutes in class tomorrow and allow you to think a little bit more clearly. All right, I hope that helps. See you in class tomorrow. Bye.